Good morning from the Laser Hut. A lot of people have been asking how we turn drawings into designs, and this is exactly one that I've picked to show you. So this particular design is going off to a lucky couple in New Zealand. So it's going to be a jewellery box or keepsake box. And as you can see here, we've got various colours that make the picture look very colourful and lovely, but obviously the CO2 laser can't do anything in colour. So what do the colours mean? Well, what we do is we basically publish the drawing to a specific piece of software, and we have a couple of settings over here, if we can see that. There we go. Right, so we have a scan layer, which we always scan first, and we have a cut layer. So anything that's in blue will have a scan of 400 millimeters a second at a laser power of 35%, and anything that is in the cut layer, i.e. coloured in red, will cut at 60 millimeters a second at 28% power. Now that cut is called a vector cut. It is not designed to go all the way through the wood, hence why we run it so fast and at such a low power. So what it does, it just tidies up the edges and makes the scanning look absolutely wonderful. So once we've figured out what all the colours mean and we've sorted them out into the order that we wish the laser to do, what we then do is we just download that to the machine and we go OK. We wait for it to download, and that's now on the machine. So we'll go over to the machine. Now that the program has been downloaded to the machine, we have to select it. So we just hit our file button, look at all our files. This has been sent over with the file name of default, and there's a little image of it there. We go, that's the one we want. We select it, and it comes up in the screen. And the other thing that we see is that our order of cuts and scans, or scans and cuts as it is, has been loaded to the machine. So now what we can do is we can set up the machine. So now we've fixed our timber that we're going to test this scan on, because this is actually going to go onto a box. So I'm going to run the job first on a scrap piece of wood, just to make sure that it all comes out perfectly. First thing we have to do is we have to bring the head into where we want it to be. So we move the head, and you can see the little red light coming in, there's the head. And what we do now is, the first thing we do is set the distance, the focal length. So what we do is get our little measuring jig, and I raise the bed until that jig just touches the wood and the bottom of the laser nozzle. That's perfect, so the height and focal length is set. Next thing we want to do is make sure the job is going to be run correctly in the position that we want it. So what I do now is I'll frame the job where the laser will go around the outside or the perimeter of the job, making sure that we have enough space on the timber to actually run the job. And here we go. What we're looking for is to make sure that that laser stays within the job, doesn't hit any of the magnets holding it down. That looks pretty good. And then we can, so just before we're ready to go, we have to turn on some air so that we don't get any smoke or debris up into the laser nozzle. So we'll turn on the air until we can hear it. We give it a decent amount of pressure. Then it's just a question of pressing the start button. And what will happen is it will start doing the scan layer first. And it's very much like a dot matrix, old dot matrix printer. It will go backwards and forwards, scanning each line at 0.02 of a millimeter. But obviously the power of that scan is only 35%, so it's only going to take out about half a mil of timber. And as you can see, it'll start running into a picture that you can actually make sense of. One thing you'll hear in a minute is the compressor kicking in to top up the air pressure, just to keep that constant. Obviously the air runs through a regulator to make sure that the laser gets the constant feed of the correct pressure of air, but it's quite noisy, and you will hear that kick in a minute. obviously scanning or engraving, as this is doing, is quite a slow process. You can imagine if this was a full bed of work, it will take quite a long time. This is one of the ways that we actually calculate how much a job is going to cost, purely by what we call laser time. And it's the amount of time that the laser is going to be operational, and it gives an idea of how we calculate costs due to time. Our wonderful little air compressor will keep kicking in just to keep that air pressure up. Thankfully it's not as noisy as your average 50 litre air compressor, because it's actually come from a dentist surgery, so it's a medical air compressor. Our new dentists were good for something. Once we get to this stage, as you can see, most of the engraving is done. It's just going to be scanning through the rest of the New Zealand map, which starts to come to life once the vectoring starts. That's when we're running the laser at 28% power, 60 mil a second, and it's actually making a cut line to score the timber, not to cut through, but to score the timber. Start to see the pattern now emerging, and obviously when the scoring starts, the vector cutting starts, then it will really come to life. As we can see now, it's running around the edge of the engraving and really making that engraving starting to pop. That's the vector cut. Some of you might be asking as well, New Zealand is 3 islands and I can only really make out 2. Well, unfortunately Cook Island doesn't have any engraving, it only has a vector cut, and that'll become apparent hopefully in a minute. Now, there we go, end of the job. Those 3 bleeps mean that the job is finished and can be safely touched. That's what we do. Turn off the air. Hopefully the compressor will stop in a second. And that's what it will look like on the top of the box. Thanks for watching.